I understand why you might have some hesitation about using auto everywhere, and indeed that's why it's almost always auto, because as you say, sometimes you do want to know that you have a 64-bit int or something as your type, and Oliver's use of 0 unside long integer are likely to be correct, but sometimes can catch you out if you're on a slightly odd platform. If you're dead keen on portability, those things can get you sometimes. So it's less of an issue now that everyone uses Linux, and Linux is 32-bit ints. Using auto everywhere can be problematic because you end up not knowing what the type of anything is when you look at your code. It means you've got to reason your way through your whole function, thinking about it, and following the train of logic. Now, of course, this isn't a problem if you keep your functions short. If you keep your functions down to, say, 10, 20 lines, this becomes much less of a problem. If you are prone to writing 1,000-line functions, then this is going to be a nightmare for you. But this use of auto in this way is not your primary problem in that case. So quite often what you see is people use auto for a few lines and then they'll tie it back down to a concrete type where they know what that type should be at some point. But it depends how many variable declarations you have per line, sort of thing, how many lines between them, because it's only when you declare a variable that you're going to be using auto. If you're just updating a value or calling a member function or whatever, that is not going to be using auto. Does that make some sense to people? Great, so we'll talk a bit more about auto soon. So we can have this discussion again once we've got a little more material under our belts. Yes, so auto for iteration can be reduce an awful lot of typing. Okay, so did anyone have any problems with getting this working? If you want to raise your hand if you've had a problem you want to discuss. Fails if they're... Yes, so this is not exactly the highest quality code, I have to admit. Although I think I'm slightly surprised. Maybe I should do this and do this live and see if I can. So. Where is my slide? Here we go. So this is obviously not going to work. So we need to change this to take a string. And we want it to say hello, then name, and then that. Have I got that right? Let's find out. Right, with a name. Oh yes, I see. Oh well. Maybe I didn't test that at all. I'm not actually sure what the The problem is, yeah, it is probably to do with CN. I cannot remember the detailed rules on when it's loading in. So part of the discussion was about reading from about using auto was why do you have to declare it before using it here? In part, this is because you need to do overload resolution on the type of the variable. So there's no way to put to declare a variable on this line and read into it. You need to pre-declare it so the compiler can examine all the possible overloads of operator, right shift, stream extraction, and then choose the correct one to turn it into a string. But anyway, okay. So let's talk about class types. Sorry, I just want to. Is this not working? Sorry, failing at computers. Okay, so a really super useful tool for doing C++, especially if you're talking about it online and want to share links and such like this, is the Compiler Explorer, also known as Godbolt. And if I click on this, it will take you to a view where you can see some code on the left. In the middle, there's some assembly. We don't need to worry about it. And there's some output on the right. So the nice thing about this is you can get links to these, and you can choose any of many different compilers. There must be a couple of hundred different compilers and versions available. And it's going to show you all the errors and warnings that compiler produces, and it can also execute your program. You have to tick a little extra box for it to do that. And you can get shareable links to your code. And one of the nice things about this is you can do sort of live coding. So we're going to have a play with this today. So let's talk about how you create your own types. So the sort of the language specification calls these class types, and you can define them using either the class or the struct keyword. So C programmers will be very used to the struct keyword. So here we have the definition of a very simple class type, which would be familiar to any C programmer. So we're going to do a very simple implementation of complex numbers. And we're going to choose to represent our complex number by its real and imaginary parts. So let's open this up on Compiler Explorer here. So if you want, you can take this link and have a look at it. Totally clickable. And this style of type is often called plain old data, or a trivial type, or an aggregate type. And what it does is it simply bunches together, aggregates together several members, each of which has a name and a type. And then you can pass this chunk of data around together and access the members individually. So if we take this very simple code, you know, it produces some assembly. I don't even want to care about it. And then it tells you what the compiler reported, and the program ran and returned a 0, which means success. So the name might be a bit confusing, I suppose. It may be worth pointing out that that comes from it's the name of the creator, Matt Godbolt. So creating these things. So if you want to create one of these types, what you need to do is you need to give the class name. And what you can do is you can list the values to be assigned in order inside the braces. And this is called aggregate initialization. So let's start doing this. And as you can see, it compiles successfully, but still doesn't do anything with it. An alternative way that's probably going to be familiar to the C programmers of you is, first of all, to define one of these variables. So we're saying there exists a complex, and I'm calling it the square root of -1. And it's worth pointing out that in this case, the values contained in it are totally uninitialized. They are just whatever values happen to be at that location in memory that gets picked for it at runtime. And then we can set the real part to 0 and the imaginary part to 1, and then we can return this to our caller. And then you can use it in this case a simple way. We're just asserting that it has the value that we want. Okay, so long asks, is the constructor is inside the function call. It is still accessible afterwards. There is no constructor here. So a constructor is a term that has a particular meaning, and this is not a constructor. This function, make imaginary unit, I guess you would call a factory function, since it makes a complex number for you. Why is complex referenced here? The complex has to be defined before this point, yes. Yeah, so since you need to have a full definition of the compiler needs to know the size of complex to be able to return one here, and to be able to actually use it, it has to have available the class definition. So in this case, we are returning by value because complex is just given as a value here. It's a pure value type. It's not a reference or anything else here. So why is the name given on the return line? Because we are creating one of these objects here, and we are giving the member initializers inside the curly braces, which is doing the initialization for us, and then we are returning this value from the function. Great, and then square root -1 is returned by value here. So we could do a very simple test here. So let's start adding stuff to our test function here. So if I could. Okay, so it compiles and executes successfully. So this is the bit that we're going to be looking at here for a successful run. And you know, this basic use of it like this should be something you're familiar with from other languages, whether that's C or Python with their attributes on a class. And in this case, any piece of code can access the member variables inside the object. Okay, so that's one way to create one of these objects. So let's talk a bit more about other ways. Marcelo asks, do you need to provide a copy constructor? No, is the short answer. The compiler does need to know how to copy the object if you want to copy it. However, the compiler can often do this for you. It can figure out how to copy one for you. So in this case, the compiler knows how to copy a double. And so since both the members are doubles, it just recursively copies the doubles. But C++ allows you to take full control of these things, kind of jumping the gun a little bit. We're going to talk about constructors during the course, don't worry. So one thing that you can do, and perhaps should do, when you're writing your classes and setting up the members, is provide default values for all your members. So instead of what we had before, I could say that I'm going to provide a default value for real part of 0 and a default value of imaginary part also of 0. So if we go in and replace this here, this will work, but we can also have complex Z1, no initialization statement, and we can assert that Z1 real part is 0. And that Z1's imaginary part is 0. And that does indeed work. So this means that when you create your object, it's going to get initialized to a known state for you. So why do I say should question mark? So one of the nice things is that the compiler will generate the code for you to set the defaults whenever you don't do this in a constructor. We'll talk about constructors soon. Even if you forget to or whatever, it's going to ensure that these things are set up in the way specified. And this is quite good for safety, but there's a reason that you might not want to, which you should always bear in mind, which is that you might want your types to act as much like the built-in types, like double or int or whatever, as possible. And if you declare a double without assigning it a value, it has an uninitialized value that you don't know. And setting it to an initialized value does incur a runtime cost, which maybe you don't want to pay if you know, you're in the middle of a loop inside the most computationally demanding part of your code. And don't forget that when you do this in your class definition, this imposes that cost on all your users, you know, even if you're not thinking about them. So you need to think a bit more carefully about whether you should be initializing these things or not. It's not a no-brain decision, unfortunately. So quick note, if you are using C++ 11, but this doesn't apply for 14 and later, you lose the ability to set the member variables with aggregate initialization by just providing them inside curly braces. If you were to try this code here with C++ 11 mode, it would complain something like no matching constructor for initialization. But this bug has been fixed in the 14 revision. So often you do want to control the creation of your instances of your classes in detail. And you do this with constructors, which are sort of special member functions. Technically, they're not functions, but to all practical purposes, they are. But they're special and they're declared in a different way. So what you can do in these is you can control in a lot of detail how you set up one of your classes, more detail than just starting from a default value or having to provide all of the members. So these are, like I said, they're very nearly functions, but not quite. So let's set up a few of these. To create one, you give it the same name as the type, and you also don't specify a return value, because in some sense the name of the class is the return value or something. I don't know. These are just the rules of the language, unfortunately. So for our complex struct here, let's declare 3. So the first one we have here, let's not do the first one first. Let's do this one here. And this middle one, which accepts only a single double, which I've called re, this one is going to initialize with a purely real value. So this is effectively a conversion from a regular double into a complex. And then we've got one much like we had before, which accepts a real part and an imaginary part. And then we have the default constructor, which is what to do in the case where you have no arguments provided to the constructor. And in this case, we have done what is called an explicit default of this thing. So why have we had to do this? Because the language rules say that if you provide any constructor that accepts arguments, then the default constructor does not exist unless you ask for it. So we could have provided an implementation ourselves, but here we're just saying it is equal to the default, which is what the compiler would have done in the absence of any other constructors. So in this case, it will just use our default initializers of 0. And this is just what the language rules say. Unfortunately, you just have to know this one. So what we've done here is we've declared them. We haven't actually provided definitions of these things. So a few things worth noting. These constructors, you can't directly call one of them, and they don't return a value in some sense. But what they do is they initialize the member variables, and they can do this before the main function body begins execution. So let's provide some definitions here. So don't worry, I'm going to talk you through this. So what I'm doing here is I'm declaring them outside of the class body. So this means that I need to tell the compiler, what am I talking about? I need to provide the namespace for this function definition, which is just the class name. And then we have to sort of step inside that scope with the double colon scope resolution operator. Then we give the function name that we want to work on. So this is a constructor, so it's just the class name again. Then we provide the arguments that are going to be used. And then inside the curly braces, you have just what is effectively a regular function body. It's just code that gets executed. But before that happens, you can use this colon syntax. And here, what happens is you can initialize the members before the function body starts executing. And in general, this is where you want to do as much of your class initialization as you can get away with reasonably. And so what you can do is you can specify the members, and it is in general, now I'm forgetting if this is an error not to do this, but you should initialize these in the same order in which they appear in your class definition. So for example, the real part appears first, and followed by the imaginary part. So I should initialize the real part before the imaginary part, which you can see I've done here. If I were to swap these around, the compiler should complain at me. Yes. So it is complaining, and it's saying that the imaginary part will be initialized afterwards. So this makes clear to me that this is not an error, it's just confusing, because you would expect that code that appears first would run before code that appears after. However, the language rules specify that the variables are initialized in strictly program text order. So these will be initialized in the other order, and so the compiler is complaining at us. gently. It's not giving an error, it's just a warning. Let's go back to where we were. Where's my... Yeah. So we now have 3 ways to create instances of this complex type. We can use a default one, which will use the default member initializers. We can just do from a single double, and we can use the 2 double initializer to set both the real and imaginary parts at once. It's worth noting that you can sort of do an implicit conversion, it's called here, where we say we're declaring 1 to be a complex and we're assigning it a value 1, and this will effectively call the 1 argument constructor for us. So let's drop that into our code now. Okay, so it's complaining because I've got all these variables set but not used, which seems reasonable enough. Okay, so member functions. Where's my member functions? So object-oriented programming is one of the major sort of programming paradigms supported by C++, and this is based on this concept of objects, which is not the same as what C++ calls an object, unfortunately. And these things contain data and code. And a feature of these objects is that the code, the procedures or methods or member functions associated with them, they can access and often modify the data of the object with which they are associated. So C++ calls these things member functions. If you're a Python programmer, you probably think of them as methods and so on. So, for example, if we've got our string name, which we've read from the console, we could modify this to say, you know, hello, Rupert, your name has 6 characters, where this name.size thing is telling us the length of the string. So to call a member function, you need to have an instance, in this case, name, and then you use the dot operator to do member access in exactly the same way as you do member access for member variables, except this is a function, and if you look up the documentation, you'll see that string.size takes no arguments. So I don't provide any, and it will return probably an unsigned integer specifying the length of the string. Okay, so how do you declare these? So you do that inside the class definition, much as before. So let's take our magnitude and drop it in to here. I'm just going to slightly rearrange this because I generally like to put the members up front, and then the member functions and so on afterwards. So here we've declared this, but we've not actually provided a definition of what the code is yet. So typically you'll declare them in the class definition and then define them out of line. So this is how you might do this. And you might notice that I've put a comment saying in the complex.cpp file, and we'll talk a little bit more about the difference between these things shortly. So this is how we might do it. So now it's complaining about the square root function being missing. So you need to make sure that you have that available as well. And for reasons, it's in the CMath header, which you know, you can look up on the reference website as well. So within this member function, we can access the members, whether they're data members or member functions, by just giving their name. We don't, because this function has a sort of implicit argument, which is the instance that is being worked on. So the compiler inserts this for us, and this allows us to look up these names without qualifying them with an object instance. Sorry, I missed a few questions from earlier, sorry. Okay, what does const mean here? We'll talk about that in a few slides' time. Basically, it's promising that this method, this member function, is not going to modify the instance it's working on. Because logically, why would computing the magnitude of a complex number possibly change the value of the complex number? Okay, so yeah, within the member function, we can access the members with just their names. I'm afraid my Fortran knowledge is too rusty to know what exactly pure means. I believe pure is a slightly stronger claim than that, because pure, it requires that if the function is called with exactly the same arguments, it produces exactly the same values, and that is not required here. I think it also can't do any I/O. I'm sorry, my Fortran's not good enough to know. Yeah, so a Fortran pure function is a much stronger restriction on the code that can run than is implied here. All you're doing here with this const is saying, I am not going to change any of the members attached to the instance I'm working on. Okay, so if you're outside the class, you need to have an instance to work on. So if we create a complex number with you know, a 3-4 triangle type one, we know that the magnitude should be 5, or approximately. I suspect this will not actually work when I do it, because I have clearly switched between integers and floats at some point, because I would be surprised if it is exactly 5. Oh, it is exactly 5. That is unusual. So let's talk a little bit more about operator overloading, because complex numbers have the usual sort of arithmetic operations associated with them, plus, minus, divide, and so on. So we can provide operator overloads for these, for things like add in place, where you can update it, or the addition of 2 complex numbers to create another one. So we've got 2 different types of operator overloads here. So first, remember, these are just functions with slightly unusual names. So this first one does the operator plus equals, and this is a member function, because this has to be updating one of the 2 ones. That's the one on the left-hand side of the plus equals operation. So we can take this and add it in. I'm just going to put the definition inside the class declaration for simplicity there. And we also have this one, which is just a free function, just a function that has nothing explicitly to do with our complex, except it accepts 2 of them as arguments and returns a new one as its result. And this this could be implemented as a member function, but for sort of reasons of symmetry and clarity, I've not done that, because there's no difference between A and B in this case. So it would be preferable to implement this as a free function rather than as a member function. We'll talk about const soon. Don't worry, Lon. So we can now start using the more natural syntax for these things, and we could say we've got z, which starts at 0. We increment it by the imaginary unit, and then we should be able to assert things about it. And then if we were to go on and provide an implementation for multiplication, so operator star and equals equals, so equality comparison, we would be able to run this code here. And there's a complete list of all the operators that you can overload. You can guess where. So I mentioned a few slides back that you can define a class with either the struct or the class keywords. And these are pretty much identical synonyms as far as the language is concerned, with one default, which is what is the default accessibility or visibility of the members defined. So members of a class type can be either public, which means that they are usable from any bit of code. So basically they're the public interface of a class, and this is the default for a struct, as in a class type declared with the struct keyword. While the private keyword means that these are only usable from within the context of the class. So it's basically something that's an implementation detail of the class that shouldn't be of any interest to code that's using it. And this is the default for class types declared with class. But by how do you overload operator addition for complex numbers, allowing for a plain double? Do I need to provide one overload for each possible signature, or does the double get upgraded? So yes, in this case, the code as written will implicitly convert a double to a complex because our class has a constructor that accepts a double, a single argument double. So when the compiler is doing its thing, it will examine these candidates for us. Now you can exclude this constructor from that process by using the explicit keyword. You will then start getting errors like it's saying here. So it's saying on line 48, which is this one, sorry, conversion from a double to a complex is requested. But by using this explicit keyword, I have excluded that as a possibility. Does that make sense? Right. So, so what do I mean by the context of a class? I mean basically this is code that is inside a member function or from anywhere else inside the class's definition. And restricting access to these implementation details is a sort of a key part of encapsulation, which is another common aspect of object-oriented programming. You can also, I'm just going to mention in passing, that you can allow particular bits of code to access private members using the friend keyword. So I'm going to try and say this with a straight face. You should only let your friends touch your private members. So yeah, if we were to try and do this, if we say have a class called greeter, so this is a class type, so its members are private by default. Thank you, Oliver. I did manage a straight face. It has a member greetie, the person that is being greeted, and it has a member function say hello that prints a suitable greeting. So if I try and use this in this function here to say hello, I'll get an error, something like say hello is a private member of greeter, and the compilation process will stop. So if I want to allow this, I need to add a public access specifier, which you do by writing either public or private followed by a colon, and then that basically switches the mode inside that class definition from whatever it was before to what you've said. And that says that all the declarations that follow can be accessed by anyone. So in this case, say hello is now a public member function, and so this test function will compile and run quite happily. So, you know, you might wonder why to bother with this, and this is useful in terms of enforcing modularity of your code. It sort of resists the temptation to go in and just access it directly, which can lead to your you know, spaghetti code where everything is reaching into everything else and it becomes very hard to make any change at all. And this can help you do things like swap out parts of the implementation for things like performance and so on without having to rewrite the client code. So like I mentioned before, a class can declare that another function or indeed another whole class as a friend, which will allow it to touch its private members. And this is a sort of a controlled partial relaxation of this encapsulation that in some ways makes the whole system more isolated. It's generally quite a good thing. Okay, so people were asking about const before, so let's talk about this. So you can say that a variable is const qualified. And what this does is it says that the object that has been marked cannot be modified through that name. And the compiler will give you errors if you try and do this. So for example, if I say I is a constant integer, and I'm going to assign it the value 42, I can print it quite happily, but I can't, for example, add 10 to it. I'll get an error saying something like cannot assign to variable I with const qualified type. And you need to be adding const quite a lot. So, you know, there's a sort of few degrees of constness available in the language. You have things that are known at compile time. So, for example, the value of pi is always 3.14, whatever. And the compiler may be able to help us here if it knows that you've set up a constant with that value, and it's const, and it could do some substitutions for you and basically compile, pre-execute those bits of code for you so they don't actually run at runtime. You might also set it on a local variable like we've done here, and the variable will get a single value for that one execution of that block of code. The compiler probably won't speed it up much, might a little bit, but it helps us mere humans because you're giving something a name so you can refer to it again. It means you won't accidentally change it. Yeah, and you can give it a useful name. So, you know, if you're doing some, I don't know, something, you could give it a name instead of like local mean density instead of just lowercase d. And maybe do this even if you're only going to use it the once, because the compiler is probably going to optimize it away anyway. So there's unlikely to be any runtime cost. Okay, so since function parameters are just local variables, they can be consts too. So I can say for this subtraction operator overload on these complexes, I can say that A is a constant complex number because I do not need to modify the arguments, the parameters to this function in the course of computing their difference. And since there's no sort of logical need for them to modify the arguments, they really should be marked as const. So member functions can have this extra const that there was a question about before. So if we go back to magnitude, it had a trailing const. And it's worth remembering that member functions have an implicit argument of the instance that they belong to. And if they don't need to change that instance, then again, they should be marked as const. So computing the magnitude of a number doesn't change it, so you should mark it as const. You can also mark a member variable as const, but in general, you don't want to do that. Just trust me on this. There was also a question about the order of the variable type and const. And basically, as far as the compiler and language are concerned, these two definitions are exactly the same. Const int I equals whatever, and int const I equals 42. The names for these things are east const and west const, because if you think about your compass, north, east, south, west, is where does the const go on your thing. So sorry, I've put east const and west const the wrong way around, because the rule for these things is that for west const, where const goes first, the rule is that const applies to what is on its left, unless there is nothing on its left, in which case it applies to what is on its right. Whereas if you use the other way of doing it, the sort of logical rule you have to use is always put const on the right of what it modifies. And this is a much simpler rule, it's much clearer. And for the language, it doesn't make any difference. But since you are all fairly new to C++, you should just use eastconst because it is more logical. The community is gradually moving towards it, but older code bases and older programmers like myself are going to be stuck thinking in the westconst way. So I'm trying to be eastconst, but I fail sometimes. Okay, so Mohammed asked, what's the difference between const double func and double func const? So the first one of these says that func accepts no arguments and returns a double that's constant, whereas the second one says func is a member function that will not modify its instance and returns a double. So these are totally different things. So for example, the second one is only valid inside a class definition. Whereas this first one returns a const double. And in general, you don't want to be returning const values from a function. Notice I said values there, not things. So the rule should be const is on the right of whatever it modifies. So in the second one, it's modifying the implicit object. Right, where's my... Okay, so references. So first, quick word about copying. So by default, if you assign a variable a new value, the language rules say copying it. So we have got saying defining a variable called copy that's a double, and I'm giving it a new value. What I am doing logically is I'm taking the little bit of memory that represents original, and I'm copying that value into the new copy variable. And if you pass the value of some type, a value of some type into a function, it's going to be copied to a new local variable for that one invocation of your function. So if I've got a function advance one time step, if I've got some simulation where I want to progress forwards in time, it's going to take in the old simulation state and return a new one. And if you're doing something complex, you know, like a big computational fluid dynamics, molecular dynamics, whatever, simulation, this current state type could be quite a big value, and it's going to be large and expensive in both time and memory to copy. If I put a const before the parameter list, yeah, so if the const goes before the parameter list, that is affecting the return value and not the parameters. You have to do it explicitly parameter by parameter. No problem. It's worth pointing out again that exactly what copying means for a type that you've defined is up to the programmer, and this is part of its interface. And we'll talk about this probably tomorrow at some point. So to help with this, C++ has the concept of a reference, which is a name that aliases an already existing value or object. And this reference has to get initialized. And for example, function arguments are initialized when you invoke them. And a reference cannot be rebound to a new object. So to do this, what you do is you qualify the type of the variable with an ampersand that goes after the type and before the variable name. So for example, here we've got this function scale vector that accepts a single double parameter, which is how much to multiply each element by. And we're having a vector, which is some sort of array of doubles that I've qualified with the ampersand here. And this means pass it by reference. And this is fairly close to the way that Fortran passes arguments to subroutines by default. So what does initialize mean in here? So this means that you can't just declare a reference variable without initializing it. And for functions, the call site is where the reference gets bound to a parameter. And the function can refer to, for example, x without copying it. Pointers, let's not talk about pointers. We're talking about references. And when I say rebound, that means you can't go, you know, int ampersand x equals 42 and then assign it to some other new value, another new object. If you assign to it, that is going to be passing through to the underlying object. Okay, so you can also qualify a reference as a const. So for example, this advance one time step thing we had before, you can say that its parameter is called old. It is a reference to a constant sim state object, and it's going to return a new thing. And so inside that, you can get your science on and then return a new simulation state for the for your caller. And what this means is that your program can't modify the contents of old through that name, and the compiler is going to give you an error if you try and do that, or if you call a function that could change it. A non-const sim state could be passed to this function. Yes, because you can always bind a reference. That is a really good point that I should have mentioned. So yeah, Christoph, that's great, thank you. you can pass in a mutable, a non-const object to a function that has a const reference, because all you're saying with the const qualifier is you're promising not to change it through that name. So that is perfectly valid. But you can't do it the other way around. You cannot pass a constant object to a function that has a non-const ref, because it could in principle modify it, which is not allowed. Great. There's my... Okay, so another thing that's worth saying is that functions can return references. There is no difference long except for readability and what people prefer. Okay, I am pro East const. I think it is more logical. Where I have failed to use it, it's just because I've been using West const for too long. Although I would say that if you're coming into a code that someone else has written, perhaps you should stick to the convention that's in that code. Or if you can, use an automatic code formatting tool to change everything to the way you prefer, which is always an option. So a lot of classes have some data inside them that they want to let their clients have some sort of access to without necessarily having to copy, without requiring them to copy. So, or you could also allow access to one single value from the many that might be contained inside an object. So let's suppose it would, oh, sorry, I accidentally scrolled. Oliver has made a confession, yes. So let's suppose we've got some list of atoms. Let's suppose this is molecular dynamics analysis or something. We have our private member data, so we've got vectors of things. So we might have three-dimensional points for the position and the velocity, and just a double for the charge of each atom. And then we can have a member function, getCharge. And what this thing is doing is it's saying, first of all, it's not going to modify the instance it's working on or any of its members, and it's going to return a reference to a constant vector. And it's going to be the value that is inside the instance. So when you come to do your analysis, you can read your data from a file somehow. And notice I've said that this is this atom's variable is const. Then we can get the charge from it, and we've explicitly said that named the type here, and we can do some calculation on it here. Let's say we're calculating the average charge of the atoms. And so this pattern of returning references is very, very common, especially if you've got container types that we're going to talk about tomorrow or the day after. No, this doesn't make the charge public exactly. This provides a way to get access to it rather than making it public. So let's talk briefly about combining auto with references and constness. So when you declare a variable with auto, you can qualify that auto with an ampersand for reference or the const keyword. So for example, you can use auto x when you want a modifiable copy of the thing on the right. East const in getters and setters. What did I put? It is good practice to use. People have legitimate differences of opinions. My slight preference is to use East const everywhere. But like I said before, I would prefer consistency with a code base over always using EastConst on the bits that I wrote. There is a strong value to fitting in with the pattern of the rest of an application, especially if it's a big thing that you're only contributing a part to. Okay, so right. So use auto X if you want X to be a modifiable copy of the thing on its right-hand side, on the other side of its equals. You can use auto double ampersand, apologies, when you want a reference that has the same constness as the thing on the right. So if you want it, if the thing is returning a const reference, this will give you a const reference to it. But if the expression on the right returns a modifiable reference, you will get a modifiable reference. This thing is called a forwarding reference, and we're going to talk about it later. No, this is a forwarding reference, not an R-value reference. Unfortunately, an R-value reference is written with the exact same syntax, Eric. And you can use auto const ref if you want a reference to the original thing and you're not going to be modifying it. So you want to generally prefer to use the last one whenever possible. Unfortunately, this is the one that involves the most typing of characters. So does anyone want to take a guess if we're thinking about that other thing? So if instead of when we're using charges, what if we just put replace this with auto? Does anyone know what the type of charges will be if I put auto there? Okay, so auto const ampersand is not a full type because it contains an auto. So okay, Matthew reckons it's going to be a reference to a constant vector. Any other guesses? So any other guesses as to what the type might be? It's not so much that the const is lost, it's that you have requested that you want a value type. You don't want a reference here. And so the type of charges will be just a vector of double with no const or reference qualifier. And what will happen is that that vector will get copied. So it will create a brand new vector for you and copy the contents in here. So for example, if you wanted to do some transformation on that data, that is exactly what you would want. If you needed to do some operation, say subtract each one from the mean to get the delta charge or something. So to get the same as you've got here, you might write auto const ref charges because you want that, and that would be explicitly communicating that you want a constant reference. You would get the same effect as if you used auto ampersand ampersand, which is a forwarding reference, because that will get the same type as there, but it doesn't communicate quite as much to your reader what you're trying to do. So if you had returned from that get charge function a modifiable reference, you would get back a modifiable reference, which may or may not be what you want. Okay. Oh, no. Yes, exactly correct. So We'll talk about this when we talk about templates, because it turns out the rules for auto deduction and template type deduction are, to a good approximation, exactly the same. Okay, compiling code. So this is sort of boring things that you just have to know. So the language distinguishes between these two concepts, which is declaration and definition. So a declaration says to the compiler, a name exists. It tells the compiler what sort of kind, what category of entity it refers to. So is it a class or a function or a variable? And if it is a function or a variable, what its type is. And for many or even most uses of that name, this is all the compiler actually means. So declarations can be repeated as many times as you like, as long as they match exactly. Whereas a definition tells the compiler everything it needs to create something in its entirety. And a definition is also counts as a declaration. So there's a rule in the language called the one definition rule that says that definitions must not be repeated, with a small exception. And so what this means is that there are conventions about where to put these things. So conventionally, one puts all your the declarations of functions, the definitions of classes, and global constants into header files, which are usually given the suffix .hpp, .h, or .H in that order of preference, but please don't use .H, because this will make some systems quite upset. And the definitions of most functions should be placed in the implementation files, whose suffixes are .cpp, .cxx, .cc, and again, .C, which you shouldn't use. And these headers can be pound included, hash included into other files that need to use the types and the functions that are declared there. So for example, we might have for our complex type header called complex.hpp that could look a little bit like this. So at the top, we have a little bit of boilerplate, which is here. This is called an include guard. And what this says, and it's talking to the preprocessor here, not the compiler technically, is that if the following symbol is not defined, complex_HPP, so this name needs to be unique for the header file in your project. So if your project is called foo and in the directory stuff, and the file is called complex.hpp, you might well call it foo_stuff_complex_hpp, because you have to take some serious care that it is unique within your globally unique within the compilation. Okay, so then if it's not defined, immediately define it. Then you have the stuff that you want to expose in your header, and then at the end of the file you have your end if, which ends the if block. So much like, for example, Fortran, where you have keywords to begin a function and end a function and so on. So much like that. And then if this header file is included a second time in that translation, for example, if you have one header file that includes it and another file includes that, and then your actual implementation file includes the 2 bits of the diamond, this will work just fine. It will only be included once. Because the second and subsequent times the preprocessor encounters this file, it will say, oh, I have a definition for that symbol. I'm going to skip it, and it will jump down to here and include nothing at all. So there's a small exercise here, which we can take a look at for the next 20-30 minutes. And if you want to work out, ensure you finished it before tomorrow. In your clone, the repository, there's an exercise called complex. So in the exercises subdirectory, there's a complex subdirectory. There's various files here. And the files complex.hpp and .cpp contain a partially working complex number class. And the test file holds some very simple unit tests. So you can compile and run it by running the make command. Does anyone not know about make? You just raise your hand or have a brief chat about that afterwards. And then you can execute the test program that's produced. And it will say, it will compile happily and then say all tests have passed once you've got it working. In the first case, this is not going to compile. But to get, like I said, say in the text, you need to complete the code, and there are a few bugs in it to fix. So you're welcome to either just disappear or start on that now, and I'll be around for at least the next 20 minutes. So if anyone has any unclarity about what make does, please raise your hand and I can do the 2-minute introduction to make. So Eric's asking about pragma once. So pragma once, okay, I'm 90% sure this is a universally supported non-standard thing. I'm not 100% sure. So I would generally not use pragma once because it is not standard. However, I'm happy to be corrected with a reference. At some point, C++ 20 modules will remove this problem for us. But support for modules is flaky across compilers at the moment. Christoph asks, yes. Okay, I'm just trying to get that open. Oh, my terminal has gone weird again. Oh, it's my connection. So. Sorry, just make sure I'm. Okay, so these are declaring who the friend is, because what I am declaring here is that this function is a friend, a function called operator equals that takes two complexes and returns a bool, and so on. Yes, because there is so much syntax in C++ to say, go and look at the reference, because there's just too much. But thank you for the question, that's reasonable. Okay, thank you, Oliver. I am now 100% belief in what I believed before. Okay, so the question is, can you do operator star for the product of two complexes, which returns a reference to a complex? Well, you could, but it will cause you a lot of problems later, because when you have a reference, this has to have an object that it's attached to. And when you return a reference, you need to ensure that the lifetime of the object carries on for at least as long as your reference holds on to it. So doing that in this case, where you're returning a reference to a temporary value, is going to immediately cause everything a crash. well, maybe not immediately, you might get lucky, but it's totally undefined as to what would happen. Unless you take that reference and copy it straight into a new value. So we return a complex by value because it is making a new value. It's not just returning to a reference to a thing that is going to exist for a while longer. Does that make some sense? Yes, if you've got the definitions all correct, that would be fine. Does it not work? So returning a reference is a bad idea. Okay? Because as soon as you return a reference to the temporary, as soon as the function returns, the object that is referred to is out of scope and has been destroyed. And that means that the memory that it's in is available for reuse by something else. And in this case, where you're having a series of function calls to this, it is going to get overwritten by probably the return value of one of the subsequent operator overload calls. So this is almost, if you use references, will almost certainly fail. The only case where it probably won't fail is if you immediately assign it to a value. So immediately copy the reference into a new value. But if your type is if you are returning a new value, you should return a new value. The compiler can figure it out for you. You may have to give it some help, which we'll talk about tomorrow, but it can avoid unnecessary copies quite easily. Okay, so it's 12:30, just after now, so I'm going to sign off and go and have some lunch. I will see you all at 9:30 tomorrow. I'll be on a few minutes early, and I'm very happy, of course, to take any questions you've got. Actually, what day of the week is it tomorrow? It's Wednesday. I will not be on very early because I have to drop children off, but I will be back shortly before 9:30. Thank you everyone for your attention, and see you tomorrow.